Good morning, everybody. My name is Tori Colburn. I am the Midwest Conservation Agronomist with American Farmland Trust. Welcome to our April 10th ICCON call. This is the last call in our three-part series revolving around soil health testing. Our first two calls, we learned about the Haney Soil Health Test and the Cornell Soil Health Test. Today, we're going to be joined by David Kleinschmidt, who's going to talk a little bit about how he uses the Haney test and soil health testing in general to help his clients make fertility recommendations in their soil health-based farming systems. So we're looking forward to that. So I think we can go ahead and get things rolling here. Want to remind everybody, please, if you would, go ahead and put your name, your organization or occupation in the chat along with your location, just so we kind of have an idea who everyone is who's joining us today. And we just want to remind everybody that we are recording this call and we will post the recording on our YouTube page later. So if you want to come back and see it again or listen to certain parts of it again, you'll be able to do that. Or if there's somebody that you know who is not able to join us today, you'll be able to forward that link on to them as well. So I think we probably have, like we usually do, I think we have a poll. Yep, we'll go ahead and get the poll launched. I'll let it give everybody a minute to answer that. And then I don't know, are we planning to show these results?
Yeah, we can share them.
Okay, there we go. Oh, good mix. All right, hopefully everybody will be very familiar by the time this presentation's over with. Okay, so as usual, we're going to go ahead and get things started with our presenter, and then we will open things up for a question and answer session near the end. And then we have just a few things that we want to go through to wrap things up, and we'll give everybody an opportunity if there's anything that you'd like to share with the group in terms of upcoming events or calls or anything that you'd like folks to know about. We'll have an opportunity for that as well. So with that, I think we're going to go ahead and kick things over to David Kleinschmidt. So David is an independent consultant who works with farmers throughout the country focused on improving their soil health while not sacrificing yield or profitability. David started Progressive Agronomy Consulting in 2018. He works with farmers to help them understand their soils are a biochemical and physical system. Together, they strategize plans on how to best manage nutrient applications, pesticide applications, residue management, and cover crop recommendations through a systems approach that best fits their needs and environment. So with that, David, I'll go ahead and kick it over to you. Looks like you've got your screen shared already, and I'll let you take off.
Hey, thanks, Tor. Glad to be here this morning with you all. And if you're watching this as a recording, it might be the evening, the morning, the afternoon, but I'm glad to be here and sharing a little bit of my knowledge on how I use the Haney Soil Health Test and some other testing for not only just cover crops, but in soils in general to understand kind of the nutrient cycling with that. Yeah, come on. So sorry about that. My screen's a little slow and a little fast. So a common myth about fertilizers is that when we apply a pound of fertilizer, that the plant is taking up a pound of fertilizer. Well, in reality, that plant is only taking up maybe about 10% of that directly. The other 90% needs to be facilitated through the soil, through basically the microbial activity or through a microbe's gut in that soil. So I always refer to it kind of like, when we feed a cow, the cow's got 4 stomachs, we know. We're real familiar that we feed the rumen first. So we're really feeding the microbes in that rumen to break down that starch and that energy and that protein. And then that's what feeds that cow. It's not just the forage that animal is consuming. So it's the same thing with our soils as well. And at most, our plants only end up taking maybe 60% of that total nutrient up as well. So I feel like too often that where we need to start is just trying to understand the whole nutrient cycle, and it's a biological system that really facilitates this. And again, one of our biggest challenges in agriculture is that a lot of people lack the understanding of this biological nutrient cycling and how that occurs. We still base a lot of our nutrient applications and management systems on a chemical based nutrient test. And I find that there's not a lot of knowledge, or it's maybe not talked about a lot, about carbon to nitrogen ratios and how that can interact and interfere with that whole nutrient cycling process as well. So when I get into talking about the Haney test and everything, and I start talking about microbial activity and carbon to nitrogen ratios, I look at carbon to nitrogen ratios on two sides, really. I look at of the soil itself to understand what my carbon to nitrogen ratios are there. And then also what is growing on that soil. If it's a cover crop, what's the carbon to nitrogen ratio of the cover crop? And also of previous crops residue. Because all of those things can maybe tie up nutrients in that profile. So here's a look at what the Haney test, and this is from Regen Ag Lab. So this is a look at what that test is looking at. And when you first look at this, it's a lot of different numbers, right? So let me see if I can't find my highlighter here. There we go. So you start looking at it, we've got, this top section right here is all nitrogen. And then over here is phosphorus. Down here, we look at pH and salts and organic matter. And then this other H3A fertility is potassium and calcium and all these other nutrients here. But where I go with this test is that it's a soil health test first. So I really focus a lot of my energy down here on this third line down here on the soil health and looking at soil respiration, the organic carbon, the percent MAC. Those are really the three big ones that I look at. And here's, for an example, here's a blown up version of it so y'all can see it. So that soil respiration is just telling us basically the activity of that soil. So the higher that respiration rate, the more microbial activity I have in that soil, and the more opportunity I have for cycling nutrients, and also the ability to maybe use more of a grass cover crop, or allow the grass cover crops to even mature a little bit more or longer ahead of another grass cash crop such as corn, so we don't inhibit the nutrient cycle too much. Too much of that carbon can actually be a bad thing. So I look at the respiration to tell me, here's an example of two fields. This one is being at 35. I consider that to be fairly low. I actually had the lowest respiration rate I've ever found was on a field in the river bottoms. It was sandy soil. So it was a respiration rate of a 7. And the next thing I look at, is this organic carbon. This differs from the organic matter, where the organic carbon is basically the water extractable organic carbon. So this is the youngest pool of carbon in that soil profile that the microbes see as food. So as the respiration rate increases, we also want to be increasing this organic carbon. But we also, this percent MAC is basically just it's a division of the organic carbon into the respiration rate to determine, do the microbes like that food that are being fed, basically. And over here, on this circled in yellow, we see that our respiration is 35, organic carbon is 96, which isn't too bad for the respiration rate, but that percent of microbially active carbon, or percent MAC, is down to 36%. So this is telling me that, potentially the microbes really don't like what cover crop is being used as much, or they're not able to break it down as quickly or to mineralize that out as efficiently as over here with this 174, 175 parts per million respiration with a 210% MAC. Those microbes love that food source. And in fact, they love it so much they're eating 200+% of it. And in that soil, we only have 83 parts of carbon down there. So eventually, without building the carbon up into this system, the microbes will actually consume all the aggregates and everything and start to collapse that system. So I go into this to understand that, this slide is incredibly important. I think this is something that a lot of guys really need to understand when we start talking about these carbon and nitrogen ratios, is that this ideal microbial diet is at 24:1. But when you have those respiration rates that are 34, maybe even 40 to 50 parts per million or less, and also it depends on your rainfall environment. And if you have less rainfall, these this carbon to nitrogen ratio for your respiration rate may need to be significantly less. But ideally, we're looking at this 24:1 ideal microbial diet. So anything below that 24:1 is going to mineralize or break down really quickly, and those nutrients are going to be released out of that cover crop really quickly. That's the same thing with our cash crop residues as well. As you look at, as it goes up here and we get into rye straw and corn stover and stuff, those are significantly higher than that 24:1. So those residues don't break down as quickly. Now, as we increase the microbial activity in that soil and we get up to 150+ parts per million of respiration rate, these higher residues or higher composition residues will break down actually fairly quickly, but you might still have the outer coating of the residue, but everything on the inside we broke down, within maybe a year to 2 years. So it's important to understand what cover crop we're going to plant in front of what cash crop to complement it and not compete it. But we got to understand really where our respiration rate is and what our microbial activity is telling us that we can or can't do there. So I always talk about this. If you've heard me talk here in the last couple of years, you probably have heard me talk about that. Our respiration rates and carbon to nitrogen ratios are kind of like building a fire. And there's really 3 things that are required to build a fire. We need heat, we need fuel, and we need oxygen, right? You can't build a fire without any of these things. So this works both in the above ground biomass and thinking about how to break it down quickly, as well as the soil microbial activity and trying to build that microbial population up quicker as well, so we can earn the right to cycle more nutrients and be able to take more credit for that. So here again, here's our Haney soil health test, and here's that 7. Here's that I referred to earlier, the 7 parts per million CO2. This farmer had been using cover crops for a number of years. He actually has really good carbon in his soils at 160 parts per million, but his percent MAC is down to 4.4. So basically, he's been using a lot of high carbon cover crops and putting it on soils that don't have a lot of respiration rate, so they weren't able to break down that residue as efficiently. They didn't like what was being fed to them either as well. So I kind of looked at this as, how do we build a fire and what do we start with? Well, going back to even trying to, if we were little and going on a camping trip, our parents would tell us to go and find a bunch of sticks and everything, and we start a fire with small kindling. And on a soil that has a low respiration rate like that, basically we've got just this little flame, and we got to use small kindling or things that are lower carbon to nitrogen ratios to start to build that flame bigger. And when we think about low carbon to nitrogen ratios, think about like a soybean plant is a legume. It's a low carbon to nitrogen ratio. these leaves are going to break down really quickly. Once they fall off and reach the soil surface, the petioles will break down a little bit slower. And then the stems will be the things that take longer to break down. So just like that, a legume like this beautiful field of crimson clover here, it's a low carbon to nitrogen. It's going to be in that 12-to-1 range. So that is going to break down and mineralize and release those nutrients really quickly. Plus, that's going to help to really build that microbial activity in that soil quick. So again, here's that small fire, and if we threw, a big 3-foot log on top of it, what happens? Well, we all know that when we do that, we basically snuff that fire out. And so think about that 3-foot log as being that high carbon to nitrogen. So basically, that's like headed out cereal rye, or even wheat, or barley, triticale, or oats. Once those crops, or those grass crops, mature and the stem elongation occurs and everything, you're going to have a lot higher carbon to nitrogen ratios. Those are going to break down a lot slower. That's the same thing with corn. It's a high carbon to nitrogen crop. Yes, it requires a lot of nitrogen to produce that crop, but there's a tremendous amount of carbon in that compared to nitrogen. So too oftentimes, well, let me back up. So here we are with cereal rye, but if we were to as we look at, Illinois as a whole here from south to north, we can do things in the south. We can grow different species in the south. We can allow things to grow a lot longer than what y'all can in the north. So a lot of times in the north, most guys just use cereal rye or barley or just a grass cover crop because they don't have time to get the legumes to establish and to really give them a whole lot of benefit. But that's okay. If we manage that cover crop correctly, if that cover crop that's just a few inches tall, 6-8 inches tall, it's going to have a low carbon to nitrogen ratio. So if we were to go in there before corn and we burn it down and terminate it early like that, it's going to break down really quickly and not tie up nutrients. Whereas this headed out cereal rye on the right here has got a carbon to nitrogen ratio of about 35-to-1. That's going to break down really slowly, and it's going to mineralize out those nutrients slowly, and it's going to tie up more nutrients. So, sorry about that. I had a couple excess. Should have had those slides in there. There we go. So a lot of times what I see is guys will plant a cereal rye cover crop ahead of corn. They let it get too mature. They seed it too high of a rate, and then they terminate it. And then they go out there, plant their corn crop. Their corn crop looks pale, and they think, well, I need to add more nitrogen. So nitrogen is kind of like gasoline. And when we pour gasoline on a fire, we get a huge burst of energy, right? And obviously, those microbes in that soil are sitting there. They had all of the carbon that they needed, but they lacked that low nitrogen source really to start breaking down some of that carbon matter. So we add nitrogen to it. The microbes are like, finally, we got the nitrogen we need. You get a huge burst of energy, and then we're left with just basically charred wood because that fuel source that we applied to that residue just got kind of tied up. And both in the microbes and in the residue, and then our crop is still suffering from that. So when we look at managing the carbon to nitrogen ratios for CO2 respiration, if we go back and look at that small kindling and that little flame that we have going on there and trying to build on top of it, well, what if we use something like oil or diesel or something like that onto that, and we just tried to slowly build that flame, and get it a lot hotter where we can start to add bigger, sticks to that. So, if we look at this, we got a 327 parts per million CO2 respiration rate. This is on a really high side with 235 parts per million carbon and 137 on the percent MAC. This is telling me right here that we can afford to do a lot of different things here because we've got a lot of microbial activity, and they really love the the carbon source that we're putting out there, we've got a pretty good balance of that. So when we put that, now that once we have that, when we start building this fire, we can start adding some bigger sticks on top of it. And then we can ultimately end up with a huge bonfire, just like that Haney test was showing with that 300 plus parts per million there respiration rate. We've got a bonfire occurring in our soils, and it takes more carbon now to keep those things going. So we've got to understand where we're at and where we're going to build this to understand how we can use cover crops more effectively and more efficiently, not tie up nutrients, and have more of the nutrient cycling. So think about this like feeding a baby. You know, us as adults, we look at that steak on the right and potatoes and corn, and man, that looks pretty good. I wish I had that for lunch today, you know, but a baby, you know, isn't going to be able to consume that diet. And a lot of times, from what I've seen, a lot of our soils, even across some of the best parts of Illinois here, 20 to 30 parts per million CO2 respiration rate, they're not advanced enough to be able to handle a lot of that higher carbon and be able to digest a lot of that residue. So we've got to think about our soils in that stage are basically like a baby, and we've got to feed them a diet that they can actually consume and break down. So that's why we feed babies baby food, right? And formula, because that's something that they can break down and digest easy. So here would be like the respiration rate for something that I'd be considering feeding baby food to, or lower carbon and nitrogen ratios, especially ahead of corn. Ahead of soybeans, I can play with that. I can build a bigger carbon biomass in front of a bean, because a bean is a legume. It doesn't need nitrogen up front. It's able to make its own nitrogen. Usually our soils in those conditions are limited on carbon. So just using this test to kind of better manage cover crops and what I'm going to do in front of different cash crops is really important there. On the other side, if we have really high CO2 respiration rates, think of that as if we've got a house of 7 or 8 boys, and they're all in junior high to high school, and they're all in sports. They're playing basketball and baseball and football and everything. They have a high energy demand, you know, and protein demand. So those guys are going to be eating you out of a house and a home, basically. And we got to make sure we've got enough food in the refrigerator to feed those. So that water extractable organic carbon is kind of that food in the refrigerator. And we want to make sure that they like that food that's in the refrigerator by looking at that percent MAC. So with those guys, yeah, now we can feed them steak and taters and corn, green beans and pizza and everything under the sun, you know. So if we don't have enough for them, they're going to start destroying the house, right? So if we've got to also think about like this soil system, if we've got a small refrigerator, a dorm size refrigerator, let's say, and we've got a house of 5 football players, you know, we can't keep enough food in that refrigerator for them. So as we build our microbial activity and everything, we want to build that refrigerator and have more food and more diverse food in that to foster more of the diet that they need. Skip through that. So here's a really cool image I found on the internet. This is of a 3D scanning electron microscope. This is a protists, and these little 3 little things down here are bacteria. And protozoa eat bacteria. So when we start talking about carbon to nitrogen ratios, it's good to understand that, you know, just like those football players and just like the babies, they require a different carbohydrate and protein demand need for their diet. Well, that's the same thing with our soils. So the bacteria, they have about a 5-to-1 carbon to nitrogen ratio, maybe less, maybe even down to 2-to-1 or 3-to-1. So basically, for that bacteria to thrive, it needs to consume 5 parts carbon and 1 part nitrogen. Well, the protozoa, it's a little bit bigger, as you can see in the picture, right? So the big fish eat the little fish in the pond. The same thing happens in our soils. So the protozoa have a carbon to nitrogen demand of 15 to 1. So they're basically going to consume, let's say, 3 of these bacteria. So 3 times 5 will give you 15, right? So that meets its carbon demands, but it only needed 1 nitrogen. Well, now it's got 3. So what happens is, well, sorry, that's wrong. That should be a 2, but 2 of the nitrogens go right out the back, you might say, just like a cow out on a pasture grazing. That's nutrients. That's part of the whole nutrient cycle. So nitrogen, phosphorus, zinc, manganese, boron, any of those elements that bacteria has in its cells, and that the protozoa or the fungi or a worm or some other type of small little insect, whatever is consuming of that soil, basically it's cycling what it doesn't need either out the back end or it pukes it back out. And that's part of the whole nutrient cycling that occurs all the time in our soils. So when I talked about in those first slides about the soils are the ones that are actually, we're feeding the soil when we're giving it fertilizer or anything. This is how that occurs, of the whole nutrient cycling process, so we can get those chemistries into our plant, or those chemicals. So the biological systems approach is really the plant. This is a plant root tip, and I don't know, I don't think it will play. Nope. So this plant root tip is basically exuding out carbon into the soil system to feed microorganisms. So the plants are through every day, are capturing sunlight through photosynthesis, or they're combining water and CO2 to make simple sugars. And the more sugar that plant has in its system, the more it's going to release out into that soil system as well. And so the more sugars we can release into that soil system, the more microbes we're feeding and fostering in there, and the more nutrients that plant is going to take in as well. And there's a whole lot of new studies out here that are looking at, like, it's termed rhizophagy, where actually that plant root is not only exuding out carbon in these sugars, but it's actually pulling in bacteria through the root tips and stripping them off of the nutrients itself as well. So the plants themselves become carnivores, basically, of that soil. So yeah, that plant is feeding microbes in the soil. It's taking in microbes, and this is all part of that nutrient cycling process as well. The interesting thing is, if we have too much soluble nutrients in that soil profile around those root areas, or the root rhizospheres, you actually see that the plants aren't releasing a lot of that excess or any of that sugar out into the system to feed microorganisms, because basically it's saying, why do I need to feed anything out when I've got all these nutrients here? Too oftentimes, though, we can't supply enough nutrients to meet the demands of that crop on a pounds per acre per day basis. And so some of those microbes, especially the fungi, if they're not attached into that plant, they can kind of go into a spore form, and then it can take up to 28 days for that spore to make that association with the root again, once the plant says, hey, I need you in my system again. So let me go on here. So another biological approach I take is this field that you're seeing right here is a hairy vetch and triticale mixed with some peas and stuff in it. It was actually a hairy vetch field that was harvested for seed. And a lot of that hairy vetch in there is basically volunteer vetch that came out of the back of the combine or shattered during harvest. So that field went back to corn. But I wanted to learn of, like, okay, if we're growing a cover crop out here, and we can take these soil tests and we can understand what the soils can provide to us, but I want to know how much is actually in that cover crop. So what I do is I take a 3 foot by 3 foot square. I clip off all the cover crop above ground or to the surface. I send it off to a lab, and they tell me what the carbon to nitrogen ratio of the cover crop was. They tell me how many pounds per acre basis is in that cover crop. And I generally try to pick an average area to do this. And then that becomes part of my nutrient management plan as well, because I can take credits on the decomposition and the breakdown of some of those nutrients out of that cover crop residue. The hairy vetch like that is going to break down relatively quickly, and I can get a pretty good charge of nitrogen out of that, as well as phosphorus, potassium, and calcium, and other nutrients as well. Whereas, you know, some of the triticale and everything, it's going to be slower, and the peas is going to be a little slower than the vetch, but not much. But basically with having a diversity of this, and you're looking at the different carbon and nitrogen ratios of different species in there all together, is I'm spoon feeding that crop throughout the growing season as each one breaks down and mineralizes at different rates. So here's an example of a cover crop analysis report of that field. Now, I've done these samples for probably the last 5 years, and I find it really important to do these almost every year because there's no 2 years alike. That same field, or a field like that the previous year, had over 180 pounds of nitrogen into it. Last year, for whatever reason, I think just because of the growing season we had all fall, the growing season we had all winter, the way it was in the spring, we had only accumulated about 79, 80 pounds of nitrogen in that. So if I would have used the previous year's numbers off a test to be a part of my nutrient management plan, I would have been way short on nitrogen. You can see here what was in that cover crop mix between my carbon to nitrogen ratio is an 18-to-1. The nitrogen was 79 pounds, phosphorus was 27, and potassium was 160. And you can look down through there and see all the rest of them. But generally, I can take, and it all depends on if it rains. Rain drives the whole system, even with the Haney test, and we'll talk about that in a minute, but rain drives the whole system. So generally, I can take maybe 30 to as much as 50% of that nitrogen credit. Phosphorus, maybe 40%. Potassium, I can take up to 80% of that. It's amazing how quick some of that potassium can release out of that cover crop. So on this slide, we talk a lot about, systems, approaches, and everything, and microbial activity. And the one thing we see is that when we work ground, so this high spike right here that I'm pointing at, this is from tillage practice. And when we work ground, we introduce oxygen into that system. So just like building that fire, we put oxygen into the system, we see a huge increase of microbial respiration. We see a huge release of nutrients immediately from that. But then over time, it starts to go back down. Well, in a cover crop, or especially a no-till system, we're not working the ground. So we kind of, as the soil warms up, we get a release of nutrients, but it just kind of plateaus and kind of feeds it all throughout the growing season. Whereas with the tillage, it kind of collapses and then just plateaus. And last year I did some tests where I was looking at CO2 respirations on no-till versus in covers versus a minimum till. And you can see, on the CO2 respiration side, with the no-till and covers, I actually had a little bit more than what I did with the tillage. But on the nitrogen side, that tillage released probably about 30 pounds extra nitrogen into that soil system. So that's really important to understand when we're talking about corn of upfront nitrogen maybe needs if we're looking at planting corn into even a straight no-till, even if it doesn't have a cover crop in front of it, that by working the ground, we get that 30 pounds of nitrogen released. So we need to look at this and say, okay, how can we get that extra 30 pounds of nitrogen? Usually it comes in the form of 2x2 applications with the planter or broadcasting some urea or something as well. So there's really three pools of nutrients in this soil profile. there's this total pool of total nutrients, and this is including organic and inorganic nutrients in that profile. It's a huge, massive amount of nutrients. And then what our typical university soil test looks at is this extractable fraction. And it's a smaller pool. It's just looking at what can be exchanged from that soil with using some fairly harsh acids that the soil never naturally sees. And so our standard soil tests basically look at, it should never be looked at pounds per acre. It should always be looked at as parts per million. And basically that soil test is just telling us the likeliness of having a fertilizer response due to the parts per million or supplying power of that soil for that region, of what type of soils we have and everything. That doesn't tell us how many pounds are actually available to the crop, right? It's just looking at having a fertilizer response. Those tests were all developed, the newest ones, which have been the Malick at that time, would have been in the 80s. The Bray test was back in the 40s, right? The plant available nutrients, now that's something that's a little different. That's what we're measuring with the Haney soil health test and all, with using water as an extractant because it rains water, looking at microbial activity, but also looking at those plants are releasing basically 3 very weak acids. Well, they're releasing multiple different acids, but there's 3 common weak acids that basically have a pH of about similar to orange juice. It's not very much, that the soil can buffer relatively quickly. But we're using those extractants that the Haney test use. We're looking at what does the plant actually see today and as a food source. So all of these nutrients are kind of go back and forth between each other. So if we apply a fertilizer here, we get some that are plant available, and if the plant doesn't use it, it can go back into this total nutrient pool. And this total nutrient pool during some rain events or with good microbial activity can go into the plant available pool as well. So it's really interesting that all 3 of these things kind of interact together. So here's the total nutrient digestion report, and just looking at the total amount of nutrients just in the top 6 inches here. And this is a sample down in Southern Illinois, but there was 3,000 pounds of nitrogen, 700 pounds of phosphorus, and 2,200 pounds of potassium. So there's a tremendous amount of nutrients in that profile. We just need to learn how to release them and how to get those to cycle back to our cash crops as well. Last year I was doing some trials and looking at doing weekly soil tests on no-till cover crop fields versus worked ground, and just looking at comparing to how much rainfall we had the week prior to sampling, and looking at the CO2 respiration rates, how they increase and then drop back down, and how that mirrored with nitrogen, phosphorus, and potassium as well. It was really interesting. Every time we got a little bit of rain, we saw an increase of microbial activity, which had an increase of nitrogen. And if the soil got too saturated, we had a decrease of microbial activity and a decrease of nutrient cycling. So there's nitrogen, and there's phosphorus, and there was potassium. It's kind of all the same. So the Haney test, like I said, it's a credit test. It's not a maintenance buildup test. So we've got to look at it a little bit differently. But basically, it's looking at what does the plant see in that soil today? How many pounds of nutrients does that plant in that soil see as food, right? So when we started thinking about it, I started thinking about, okay, that plant, let's say 180 bushel corn crop, doesn't take out parts per million. Well, it looks at pounds per acre per day, right? So if we're to look at, a 4-inch corn crop, 20 days after seeding, it's looking at its nitrogen uptake is about 1.5 pounds per acre per day. Phosphorus is 0.15, potassium 1.3. You start breaking this down and thinking about a per bushel per day, it's a very, very small amount, 0.08 pounds of nitrogen per bushel per day. 0.0008 pounds of phosphorus per bushel per day, 0.07 pounds of potassium per bushel per day. But as that plant grows, it's changing, and it's going to have an uptake pattern of more nutrients at different times throughout its whole life, all the way through R5. So that doesn't seem like a whole lot until you start adding it up. Okay, if this is 20 days worth, this is 30 days worth, this is another 15 days worth. You add it all up, and the total nutrient uptake for a 180 bushel corn crop is about 450 pounds of nitrogen, 58 pounds of phosphorus, 357 pounds worth of potassium. Now that's not product, that's actual pounds of nitrate or ammonium. That's actually P2O5, that's actual K2O. So you divide that by, let's say you're using anhydrous, you divide that 448 by 0.82 to get pounds of product. That's a tremendous amount of product. There's no way we're applying that much. I mean, there's 600 pounds or $600 worth of nutrients per acre, 180 bushel corn crop would be taken up. So there's no way we're feeding that much. So there's, let me go into here real quick. So when I look at these soil tests, I don't look at doing this on a grid test. These are extremely expensive. So I want to look at using zone sampling and picking out areas of the field that are most alike, looking at water flow and everything like that, and using zone samples to determine where I'm going to select these areas I'm going to sample from, or I'll do composite sampling. So let me skip through some of these slides here. We're getting short on time. But there's another test. This is a pretty cool test. This is from Next Level Ag Lab. It's combining both the standard soil test plus the Haney test plus the total nutrient digestion. So it's looking at 75 plus metrics of that soils and its ability to supply different nutrients. But I want to get into really quickly, I'm going to slide through all those. So here's how I use this. Like I said, this is a credit system. So our standard recommendations would be looking at 1.2 units of N per bushel yield goal, 0.38 pounds of phosphorus and per bushel yield goal, and 0.27 pounds or units of K or potassium per bushel yield goal. So that'd be like 276 units of N, 87 units of phosphorus, and 62 units of potassium. And you can see there's 336 pounds of anhydrous, 190 pounds of DAP, and 100 pounds of potash to achieve 230 bushel corn. Well, by using the Haney test and by taking the credits on the nitrogen and the phosphorus and potassium that test would show, I use 1 pound of N per bushel. And then I subtract the credit. And then if I have a cover crop residue, I take about, like I said, maybe 50% of that. And then for the phosphorus, I use a 0.3, subtract off the Haney credit phosphorus, subtract off a cover crop credit on that phosphorus. For potassium, I use a 0.22. I subtract only 60% of that Haney test K credit. The reason I do 60% is because potassium is all determined on if it rains, really. The more moisture we have in that soil and the wetting and drying effect of that is going to release more potassium. And potassium is really intertwined with nitrogen uptake in that plant. So I don't want to short myself on potassium, but I don't want to use too much as well. So I'm going to take about 60% of the credit for the potassium. For the cover crop, I'm going to take about 80% credit. So you start looking at, let's say, here's that cover crop analysis report, and if we took, the credits off of that, it shows that, well, I'd only need to raise a 230 bushel corn crop here, maybe only 150 pounds of nitrogen. I don't, I've got an excess of phosphorus, so I don't need any DAP, and I've got an excess of potassium there, so I don't need any potash. So you start looking at the differences here. Yes, the test is more expensive. It's a lot more expensive than a standard soil test. But by adding all these metrics together and trying to be better managers of our system and taking these credits, it the cost outweigh the benefits outweigh the cost here when you start looking at the dollars per acre savings and not sacrificing yield at the same time. So with that, do we have any questions?
Thanks, David. That was really, really awesome information, especially that last slide. I'll definitely be going to that in the future. So we did have one question in the chat from Michael, which I think we've kind of covered with this last slide on how to take those fertilizer recommendations and actually apply those. So if Michael, if there is still other questions on that, please do come off chat or off mute. And then let's see. We've got a time for just a couple of questions, and I'll let Tori cut me off when we're out of time here, so we can do the outro and get your CCA credits and everything. But one question that we had is, so of current adopters of conservation practices, so those already using cover crops and no-till, that kind of thing for maybe a while now, what is the biggest thing that you're finding that they're doing incorrectly, that they could shift in their system to get better benefits?
And honestly, this test is what's telling me that. If you go back to looking at that one Haney test, that guy's been using cover crops for about 12 years. He's been using no-till, and he's a really good farmer. He's really good management, but he's been using very high cover crops, and he's never had a Haney test done, and a lot of farmers never have. So they don't know what their microbial activity is. And so basically you're putting that a high carbon on a little fire that was just started with twigs, and it can't overcome all the carbon. So that's where this test really has its benefit, I think, is looking at, even with a guy that's been doing cover crops for a long time, we've got to understand where our soil respiration rate is. We all talk about soil health, and everybody wants to talk in this cover crop world about earthworms, but that really doesn't tell you about what's actually in there, how microbially active are our soils, and how much food is in that soil, and do they like the food they're being fed. So that's where the huge benefit of this test comes in, just as a soil health test. But then even looking at, every time we apply fertilizer, we're applying a lot of salt on that soil as well. Salt, it has a negative impact on the microbiology of that soil. So if we're looking at this Haney nitrogen, looking at the available phosphorus, and looking at the potassium and taking credit on that, there's other things I look at in here too, in terms of iron and aluminum and calcium to phosphorus, different ratios as well, just to determine to make sure nutrients aren't being tied up. But if we were just to take those credits off of here, we're not applying as much salt onto that soil, and we become better managers of that. That can actually increase our respiration rates and increase the microbial function of the soil as well.
Awesome. Thank you. We did have another question come in chat here from Charlene. Let's see. Looks like they're in Hancock County, and they're wondering what the best soil lab is for them to use. So can you speak to just broadly, in Illinois, where should people be sending these samples?
There is no lab in Illinois that does these tests. Okay, so this test by Regen Ag Lab is in Kansas, Pleasanton, Kansas. Next Level Ag Lab is in Alpena, South Dakota. Ward Lab in Kearney, Nebraska. I'm sorry, I said Regen Ag Lab is in Nebraska as well. I'm sorry if I said Kansas there. The Midwest labs and some others do a Haney test, but I primarily use the Regen Ag Lab and Next Level Ag Lab. But if you have any questions, just reach out to me and we can talk about different labs that are out there as well. But as far as soil health tests in Illinois, there's no lab that's doing it, to my knowledge. Some are taking them and actually sending them off to these other labs.
Awesome. Thank you. Tori, we got time for one more?
Yeah, absolutely.
So we talked about what maybe cover croppers and current adopters are doing wrong, and what their first steps maybe to look at are. What about for those guys that are looking to kind of get into the reduced tillage, into the cover crops? Where should they start? Do they start with a Haney test? Do they start with just playing around with a few cover crops? Where should they start?
It's part of a system. It's management. For the cost of that Haney test, for the Haney test alone is about $55. I think it's really important that you start with that test to understand where you start and to know how to better manage that cover crop. Without that test, you're shooting from the hip, and you don't know what your target is. So I think we've got to start with better testing before we even go into using cover crops. There's too many failures out here with cover crops, and I think it's because guys have never tested their soils and don't understand the biological function of their soils. Yeah,
absolutely. I think we'll maybe cut it there, Tori. We've got, I think, maybe an exit poll, and then we've also got some CC credits.
Yep. I guess I would just the added comment, David, feel free to respond to this if you'd like, is that one of the things that I've heard from a lot of cover cropping farmers who've been very successful in doing it, some have used Haney tests, some haven't, is that if we're going to actually realize all of the benefits of using cover crops, a lot of times we talk about reducing soil erosion and weed suppression, and we touch on nutrient cycling, but we don't really know what that means from an economic standpoint. These tests are a good way to kind of get a handle on some of that. And we talk about, well, if I'm going to cover crop, I need to know that it's going to pay. Well, this is where you can see some of the value when it comes to dollars and cents. If you're able to cut back on using some of your inputs, you're going to be saving money in that regard. So, you can't manage what you don't measure, I guess, is kind of what the take home is.
Absolutely. And even when I was doing those weekly soil samples and looking at the pounds per acre per day demand of that cash crop or that corn crop out there, if you're starting out with and saying, well, I've only got 30 pounds of, let's say, potassium out here. Well, looking at the potassium that plant takes up, by the end of the year, I should have been negative, but I wasn't. That soil is still able to supply those nutrients. So that's all I'm measuring with that is how much is the soil able to supply per acre per day, basically. And it's all part of that management system. I also noticed real quick, somebody in the chat had asked about the best time of the year for the Haney test. I primarily like to do it in the springtime. Once the soil temperatures are at 2 inches depth or at 50 degrees with a good warming trend, mainly because when I'm looking at it and trying to use it as a nitrogen management tool, I want to see ahead of my corn crop how much nitrogen I can reduce by. When you go further north and you guys up in the north happen to freeze, we don't do that down south anymore, I don't feel like. So our nitrogen is kind of up in the air and kind of up for gamble, and we're measuring the nitrate and the ammonium side there. So doing fall samples could work for the guys in the north. But again, biological activity slows down once you get below that 50-degree range. So I try to do it with 50 degrees and warming, as that's going to increase the biological activity of the soil. Don't really want to do it on saturated soils. Really don't want to do it on really, really dry soils either, because that's going to skew the results. And we've got to make sure that we're doing it at a consistent depth, because the test is calibrated on depth. So either a 0 to 6, 0 to 7, or 0 to 8, whatever. Just make sure you're consistent with all your samples.
All right, appreciate that. At this time, I guess I'll give the quick pitch on the ISAP Illinois Soil Health Leadership Program. If anybody would be interested in becoming a soil health ambassador, this is an 18-month top-notch training course. Frank and I both just completed this training. So anybody who might be interested, please feel free to visit the link. I think we can drop that in the chat. Wonderful training. It's an 18-month course. Most of the training events are going to be 2-day events, but it's a good opportunity for you to get together with other soil health minded people around the state, get some great training from experts, industry professionals, so on and so forth. So we're going to be accepting applications into this soil health leadership program through the end of May. So please, if you're at all interested, take some time, fill out the application, and we're hoping to get, I think, probably what 30 or 40 folks enrolled in this program for this next round. So would greatly appreciate anybody who's interested in filling out that application and become a soil health ambassador. I guess I will also note that we are going to be taking planting season off from our ICCON calls to allow everybody to get crops planted and not worry about missing any valuable information from these calls. So I guess at this point, I'll kick it to anybody who has any other events or opportunities or any suggestions for future calls. Anything you'd like to hear more about? Maybe things we've touched on lightly in the past that you'd like to dive further into. If there's anything anybody would like to share, now is the time. If not, that's fine. We will go ahead and move on. I think we've got our code for CCA credits. So if anybody is a CCA, take time now to scan the QR code. If you don't have the app, you can email Rachel. Her email address is there. We'll go ahead and launch our exit poll. And I guess as long as we've got all our results in, I just want to thank everybody for joining us again today. And always, it's a good crowd. We very much enjoy hosting these calls, and we appreciate everybody coming and having good conversation. David, thank you very much for your presentation today. Very informative. Glad you were able to join us, and I hope everybody has a safe planting season. And we look forward to seeing you again next time. Thanks, everyone.